Okay, let's evaluate some trig functions. We have been doing this, but now we are going to use some of the new identities that we just talked about to expand what we're able to evaluate. Okay, so step one is determine the quadrant for where our reference angle is going to go. And then we're going to build the triangle. And by the way, this is not necessarily the unit circle, okay? This is just any circular function, meaning we have an angle that starts over, our theta starts over on the positive x-axis and opens up counterclockwise, but the hypotenuse is not always 1, okay? We're going to use the information that is given to build the triangle, meaning to label the sides of the triangle, okay, which is step 3, and then we are going to use whatever necessary to find the missing side, which generally is going to be the Pythagorean theorem. And then we will evaluate the trig function. Okay, so a couple things to add here. When we label the known sides, we want to include the sign of x and y. And by sign, I mean S-I-G-N, okay? So we want the signs for x and y, meaning in an ordered pair, if we have a point that is to the left of the y-axis, it has a negative x value. If it's below the left of the y-axis, I don't remember what I said. If it's below the x-axis, it has a negative y value, okay? So keep those in mind. And also the hypotenuse is always positive. Always positive, greater than 0, okay? What else are we going to be using? You guessed it, SOHCAHTOA, okay? We're going to be using that a lot to fill in missing sides or find the remaining values. Okay, so for these two problems, we are looking for the sine of theta. We are given some information about theta. In this case, we are given that the cosecant of theta is equal to negative root 10 over 3. Okay, so we're going to start by figuring out where this goes. If cosine of theta is negative, okay, that means we have to be either in quadrant 2 or 3. So this piece right here tells us quadrant 2 or quadrant 3. But then also cosecant is negative. If cosecant and therefore sine is negative, this information means that we have to be in quadrants 3 or 4. So between the two of these, what quadrant do we have to be in? We have to be in quadrant 3 because that would satisfy both of the signs, S-I-G-N, for theta, for these ratios, okay? All right, so we know we're in quadrant 3. So I'm going to just put a ray down here in quadrant 3, and then I'm going to make my right triangle by drawing a segment to the x-axis. We always go to the x-axis. Okay, so this is our theta here, and it tells us that the cosecant of theta is negative root 10 over 3. Well, cosecant is a reciprocal of sine, so I'm looking up here, SOHCAHTOA. The reciprocal of sine means we're going to do hypotenuse over opposite leg. So this is hypotenuse over opposite leg. Now between the two of them, I just said that hypotenuse is always positive, so I'm going to keep that negative 3 with, the negative with the 3. So my hypotenuse is root 10, and my opposite leg is negative 3, okay, which is this distance down here. Now, what is it that we are looking for? We are looking for sine of this angle. In order to write sine of theta, I need to know the opposite leg and the hypotenuse, which, wouldn't you know it, we actually already have. So the sine of this angle is negative 3 over 10. Now, you may be saying to yourself, hey, Miss Rice, we already know that sine is the reciprocal of cosecant, so why can't we just flip it over? We can, but here's the reason that I went through this process. In the homework, if it's going to ask you to find all of the remaining 5 trig functions, we need to have a complete triangle. So let me go ahead and finish the triangle. Let's switch colors here. And so this side right here, this x coordinate here, I'm going to use the Pythagorean theorem to find that. So the leg is going to be the square root of hypotenuse squared minus leg squared. So the square root of 10 minus negative 3 squared is 9. Root 1 is 1. So x is equal to 1, but actually since it's going to the left, this side is -1, okay? So then if I was filling in the rest of them, I would do cosine theta equals -1 over root 10, tangent theta equals opposite over adjacent -3 over -1, which is just 3, etc. Okay, and so that's how having the complete triangle allows us to fill in all 5 of the remaining trig functions based on the one that we're given. Okay, second example here, it says cosine of the opposite of theta, or negative theta, is equal to root 3 over 6. Okay, and this is a positive number, so the fact that this is top positive tells me that I'm going to be in either quadrants 1 or 4. And then also our symmetry identities tell us that since cosine is an even function, cosine of negative theta is the same as cosine of positive theta. So I'm going to go ahead and write that down, that this is the same as cosine of theta, and now I can ignore this negative part. Okay, it also says that cotangent is negative. If cotangent is negative, cotangent and tangent, because they'll have the same sign, that means that I am either in quadrant 2 or quadrant 4. So based on this information, that tells me I need to draw my triangle in quadrant 4. Okay, so I'm going to do that. I'm just drawing a ray here. I'm really not worried about trying to draw this to scale. I just want to make sure it's in the right quadrant. Okay, then I draw the line to the x-axis always, never this way. And that's a right triangle. Here is my theta. Okay, and so I know that the cosine of this angle is root 3 over 6. I know that cosine is adjacent leg over hypotenuse. So my adjacent leg is going to be root 3, and my hypotenuse is going to be 6. Okay, I need to figure out this coordinate right here, which we'll label y because it's a vertical coordinate. And I do know it's going to be negative, but we'll go ahead and use Pythagorean theorem to figure out what the positive of whatever this is. So leg is equal to the square root of the hypotenuse squared minus the other leg squared. Root 3 squared is 3. So this is root 33, but actually the side is negative root 33. Okay, and actually if you want to just put negatives inside there, you can. Okay, so that leg is negative root 33. All right, so we are looking for sine of theta. Okay, so sine of theta is equal to the opposite leg, negative root 33, over the hypotenuse, which is 6. And we cannot reduce 33 and 6 because the 33 by 3, because the 33 is under radical. So we're done. And again, we could then use this triangle to fill in the rest of the trig functions or the rest of the ratios, but we do not need to for the notes here. Okay, I think we get it. All right, moving on. Here we are going to be rewriting our expressions in terms of sine and cosine, and then we are going to simplify. When we simplify, sometimes simplification looks a little bit different, but our idea here for simplification is that there are going to be no quotients, meaning no fractions. Okay, so no fractions. All right, in other words, instead of having 1 over sine, I should change that to cosecant. Okay, and then also we have a single theta inside each of our functions, as opposed to like a negative theta or, you know, I don't know, 2 theta or something like that, which I don't think any of those will come up, but no negatives. Okay. So we have cosecant times cosine times tangent. Again, we're going to start by writing in terms of sine and cosine based on the identities that we know. So this is equivalent to 1 over sine of theta times cosine of theta times, and tangent is sine theta over cosine theta. Okay. Now, the thing about algebra is that any factor in a numerator can be reduced with any factor in a denominator if all of those are being multiplied together. Okay, so when I look at this, I see a cosine in the numerator and denominator. If you want to turn this into a fraction, just put it over 1. So I'm going to cancel out the cosines. Also, I have a sine in my numerator and denominator, so I'm getting rid of those, and I am left with 1. That reduces to 1. Okay, for sine times secant. Okay, so that would be, sine is already in terms of sine. Secant is 1 over cosine. So I'm switching secant out and writing that as 1 over cosine. And now I want to combine those. I can't reduce anything, but I do have an identity for sine divided by cosine, and that is that it is equal to tangent. So again, got rid of my fraction and just wrote it as a single trig function. Okay, here expanding our algebra skills a little bit. Secant theta minus 1 times secant theta plus 1. I'm going to actually come back to this real quick and remind us of some algebra things. When we multiply conjugates, okay, when we multiply conjugates together, it's the same thing as squaring the first, so a squared, squaring the second, the b squared, and putting subtraction between them. Okay, so when I see secant minus 1 times secant plus 1, I could write out like all of the distribution with, you know, my first, my outer, my inner, my last. I could write out the whole distribution, or I could recognize this is the product of conjugates, meaning I can square the first, secant squared theta. I can square the 1, and put subtraction between them. Okay, you would get the same thing if you did secant times secant plus secant times 1 minus 1 times secant minus 1 times 1, because the middle two terms would cancel out. Okay, here's the thing though, I can go a little bit further than this. If you remember from our Pythagorean identities, tangent squared of theta plus 1 is equal to secant squared of theta. I have secant squared minus 1, meaning this is equivalent to tangent squared of theta. Okay, so here we use the Pythagorean identity to simplify one step further. Okay, on number 4, we are going to use a few identities. First, when I see 1 minus sine squared, even though it has a negative theta in there, again, I'm thinking about the Pythagorean identity. Anytime you have something plus or minus 1 and the trig function is squared, you should be checking to see if it is a Pythagorean identity. In this case, it is. Since sine squared plus cosine squared is 1, 1 minus sine squared is going to be equal to cosine squared. So this is now cosine squared of negative theta. And then 1 plus cotangent squared is equal to cosecant squared of negative theta. And if you don't have those memorized yet, no big deal. Just scroll back up and look at your, or flip back to the front side and look at the identities, okay? And then from here, I can do a little bit more rewriting. My instructions did tell me to write in terms of sine and cosine, so I'm going to take this cosecant squared and I'm going to move it up. Okay, 1 over cosecant squared when I move it up becomes sine squared. So now I have cosine squared of negative theta times sine squared of negative theta, and the order does not matter. Okay, and then I'm going to use the symmetry identities. Cosine squared of negative theta is the same as cosine squared of positive theta. Okay, sine squared of negative theta, well, sine is equal to, sine of negative theta is equal to the opposite of sine theta, okay? But let me write this off to the side here, or off to the side. So this is going to be the opposite of sine theta, but that is squared. A negative squared still becomes positive, so I'm still multiplying by sine squared theta, not negative sine of theta squared, okay, or negative sine squared theta. All right, so it does become positive. Okay, and I guess I don't really need the parentheses here, but it doesn't hurt to write them. I do encourage you to write them if you are putting a negative in here, otherwise it looks like you are subtracting. Okay, next one, so we have sine theta minus cosine theta and cosecant theta plus secant theta. We need to change the cosecant and the secant to be in terms of sine and cosine. We can either do that now or we can multiply and then do it. I'm going to recommend that we do it now though, because it's going to simplify our multiplication process. So I'm going to write this as sine theta minus cosine theta times 1 over sine theta plus 1 over cosine theta. Okay, now when I distribute, I have sine theta times 1 over sine theta, which is just 1, and then sine theta times 1 over cosine theta. I'll go ahead and leave it like that and change it in the next step. So sine theta over cosine theta minus cosine theta times 1 over sine. So cosine over sine. And then minus cosine times 1 over cosine. That's just 1. Okay, 1 minus 1 is 0. Get rid of those. And then I don't want these fractions. Sine over cosine is equal to tangent minus, and cosine over sine is equal to cotangent theta. Okay. Next one, number 6. I'm going to start by splitting, and you can do this in either order. I'm going to go ahead and leave the negative for now and start by splitting sine of negative theta into, tangent of negative theta into sine of negative theta over cosine of negative theta, but you could also use the odd identity first. It really does not matter. You'll get to the same spot. So I'm going to write it as sine negative theta over cosine negative theta, and then secant theta is 1 over cosine, so it's going to come up to become cosine of positive theta, okay? Now, these don't reduce as they are, but I do know from my symmetry identity that cosine of negative theta is the same as cosine of positive theta, okay? So let's do that in 2 steps. Sine of negative theta is the opposite of sine theta, and then cosine of negative theta is the same as cosine theta. And now the cosines cancel out, so we end up with negative sine theta. Okay, a couple more. I would recommend at this point that you pause the video, try them on your own, and then resume and see if you got the same thing I did. Okay. For this one, I noticed that I have a cosecant squared and a negative cotangent squared. From my Pythagorean identity, I know that cosecant squared minus cotangent squared is equal to 1. So I'm going to combine those as 1 plus sine squared theta, and I'm done. This looks like it might be another Pythagorean identity, but that would only be cosecant squared if it was 1 minus sine squared. Now, could I replace the sine squared with 1 minus cosine squared? I could, but then I would just have 2 minus cosine squared, which isn't any more simplified than this one. Okay, oh, forgot my equal sign. Okay, and then secant minus cosine. So I'm going to start just with the other ones as writing this in terms of sine and cosine. So I'm going to write it as 1 over cosine theta minus cosine theta. Okay, now we need to do a little bit of algebra. I'm going to try and simplify this so that I don't have a fraction, but also I don't want to just go back to secant. Okay, so what can I do? I can get a common denominator. To get a common denominator, I'm going to multiply by cosine theta over cosine theta, because then I would now have both over cosine. So I get 1 over cosine squared theta minus cosine over, backing up. Sorry, only cosine in the denominator. So 1 minus cosine squared, that's where that goes, all over cosine theta. Okay, 1 minus cosine squared theta is equal to sine squared theta. Okay, and at this point, sine squared over cosine is nothing. Sine over cosine, though, is tangent. And then I have a sine left over. So I'm going to write this as sine theta times tangent theta to get rid of the fraction. Okay, last section here. This is matching. We are just looking to see which expressions in the first column are equivalent to the expressions from the second column and are an identity. Okay, so a few ways to approach this. When I look at it, the first thing I see on the first one is that I have sine over cosine, both being squared, so I can write that as tangent squared. Now, I don't see a tangent squared x in column 2, but I do see this. 1 over cotangent squared is the same thing. Let's move that up with the reciprocal identity. That's the same thing as tangent squared. So 1 and c are the same thing. Okay. For negative sine times secant, I am going to write this secant in terms of cosine. So negative sine x, and move that down and change it to cosine. Negative sine over cosine is the opposite of tangent. So now I know that this is equal to negative tangent x, okay? Coming over to this side, that doesn't have anything to do with tangent. This one does. D does not. So let's come back to B. Tangent of negative x. I know that tangent is an odd function, so tangent of negative x is equal to the opposite of tangent of positive x, meaning those two match. So this one is B. Okay. Sine of negative x, because sine is odd, is the opposite of sine x. Again, looking over here, A and D, I got a squared, that's not it. Down here, I have a negative, but then I also have 1 over cosecant. I can move cosecant up to be sine x with the reciprocal identity, so those are the same thing. And by process of elimination, I know that this one's going to be a, but let's go ahead and check. Cosecant squared minus cotangent squared is the same identity, same Pythagorean identity in the same order that I had up here on number 7. So cosecant squared minus cotangent squared is equal to 1. So this is 1 minus sine squared x. 1 minus sine squared x is equal to cosine squared x by the Pythagorean identity. So A is correct.